Good evening, everyone. Welcome to the first PiMora session. This is a series of sessions organized by the Spark branch of the Electronic Club. First of all, I'd like to apologize for the delay in announcing the shortlisted teams, but we'll be announcing them by the end of today's session. Each and every shortlisted team will receive a brand new Raspberry Pi computer to kickstart their projects. So, some of might may already know about this, but many contestants are not yet familiar with how to work with a Raspberry Pi. So, this series of session series is specially for you. We'll start from the basics and gradually go deeper session by session. So, stay with us throughout the series. By the end, you'll have a much clearer understanding of Raspberry Pi and how to use it effectively. All right. Enough talking for now. Let's get into today's session. Today we'll begin with an introduction to the Raspberry Pi. To conduct the session, I warmly invite Mr. Sahas, a third year ENTC undergraduate. Hope you all will actively support and engage throughout the session. Sahasaya, over to you.
Yeah, so thank you, Nipun. So, first of all, thanks for your introduction. So, I'm Sahas, as he has mentioned, I'm a third year undergraduate of ENTC, and also I'm currently doing my internship in WSO2 as AI and robotics engineer. So, moving on, let me share my screen. Yeah, I hope you all can see my screen. So when talking about the Raspberry Pi, I I like to give a brief introduction to Raspberry Pi today, and also moving on, I would like to give you a little info about the ROS 2, the robotics operating system info as well. So this is the slide deck I have taken from Odilaya, and I would like to mention that also here. So moving on, what is Raspberry Pi? So do you guys have any idea about what is Raspberry Pi? So a Raspberry Pi can be introduced as a credit card size Linux computer. So here a Raspberry Pi comes with different types, cost, and various capabilities. So when talking about the types, we can see Raspberry Pi Pico and also Raspberry Pi 3, 4, and also there are submodels as well, like Raspberry Pi 4B and so on. So when talking about the cost, this Raspberry Pi computer is low on cost compared to the capabilities that it is providing. So and also it is providing a very good open source community so that you can get a good knowledge and also good resources from the internet as well. So then let's move into the main parts of the Raspberry Pi. So here, as you can see, there are so many parts in this small size, or we can say a credit card size computer. So here, first we can see a 40-pin general purpose input and output headers, which supports us to give inputs and also get output based on the different protocols and also with the several communication protocols as well. So then there are like these POV headers. These also can be used to power the Raspberry Pi, and also there is like gigabit Ethernet pin where we can use that to connect with Ethernet to the Raspberry Pi, and also there are like USB pins, and then there are stereo audio port which we can use to connect audio output, and also there are this two-lane camera port. So here we can use this port to connect a Raspberry Pi camera, uh, and then there is like two HDMI ports which we can use these ports to connect displays, and then this is the power jack, and then there is also a two-lane display port which can be used to connect a LCD display. So, and also this is the micro SD card slot and this Bluetooth as well. So these are the main parts of a Raspberry Pi. So then moving on, what are the operating systems we can use on the Raspberry Pi? So in a Raspberry Pi, we can use the Raspberry Pi OS inherently. So apart from that, we can use a lot of OS, and we can use those OS based on our application. So if you are doing a robotics task, it will be most probably useful to use Linux, and also if you can use any other OSs based on your task. So then this is the one of the most important thing, how to install the OS. So there are several ways in installing the OS. So one of the method is install the Raspberry Pi OS using Raspberry Pi image. So here with this is the Raspberry Pi image, and you can download this using a official site, and then install, and then you can insert a SD card, insert the SD card actually using a card reader to our desktop, and then we can burn that SD card using OS, and then we can put that into our Raspberry Pi, connect a monitor using our HDMI port and keyboard and mouse, then we can operate using that. Sorry. And also another alternative method is use snoops or pin. So in these methods, so let me show you. So if you like to use snoops instead of Raspberry Pi image, you can download snoops, and then you can put the Raspberry Pi, then you can put snoops into your SD card, and then you can plug it into the Raspberry Pi, and then you can install any OS in the Raspberry Pi itself rather than burning it from your computer. That's also an alternative method for installing Raspberry Pi. So in this article, you can see here, you can see the different OSs you can choose. So yeah, so moving on to our presentation. So there is another something interesting thing available. It's that we can use two monitors as well using the two HDMI ports. So in this article, you can see how to connect two monitors and also connect those as a one monitor and use as well. So you can refer it later if you like. So moving on. So after installing your OS on your Raspberry Pi, you can use SSH protocol to communicate with your Raspberry Pi. Using this protocol, you don't need to have a monitor, and you can communicate and you can execute any functions, any codes in your Raspberry Pi without using any monitor, keyboard, or mouse. So in here, it's like operating Raspberry Pi with your computer itself. So that's it about SSH. And also there is another protocol name, another method you can use to work with Raspberry Pi is use real VNC kind of software. So using a real VNC, you can use Raspberry Pi as you can see it, not as SSH, you can see what's happening from your laptop. So let me show you how to set up. Yeah, so in here, in this article, it's mentioned how to set up a Raspberry Pi to work using real VNC. So in there, it's mentioned how to install OS. So moving on, here we can see how to use VNC. In here, what you mainly have to do is to install the software named Real VNC, and then it pops a screen like this. So in there, what you have to do is to find the IP of your Raspberry Pi, and then you have to paste it in here. And also, one thing that you have to remember is that you have to connect both your Raspberry Pi and your laptop into a same Wi-Fi network. So moving on. Yeah, so here it's also mentioned how to do the configurations. So you can try this later if you like in this method as well. So yeah, then moving into our presentation again, there is there are so many other methods as well to use your Raspberry Pi without bothering to connect to a monitor. So one another thing is to use XRDV protocol, and also you can use SSH, and also another so smooth way to use is no machine. But no machine is not a fully open source protocol, so there you may need to pay for the service. So apart from these things, there is another good way you can use a Raspberry Pi as a Raspberry Pi without connecting to a monitor is to use a capture card. Using a capture card, you can connect Raspberry Pi to your laptop, and with the capture card, your monitor's HDM, your monitor, your laptop can work as a monitor. So in here, you have to connect a keyboard and mouse to your Raspberry Pi, and then also you can work it as a computer itself. So yeah, in here also the method of configuring XRDP is also mentioned. So I think we can share this slides with you later, and so you can refer if you like. So moving on, as I have mentioned previously, if you are hoping to do some work of robotics with your Raspberry Pi, it is advised to use Ubuntu or any other Linux environment. So here it's mentioned how to install Ubuntu 22.04 version in your Raspberry Pi. As this is also same as installing the previous OS version, I'm not going to explain this much more. So, so I think this will be something interesting to you to understand. So if you are using a Raspberry Pi, you may have your applications, or you may hoping to use it with several projects. So one of the main things that you can use a Raspberry Pi is to use it as a IoT platform. So in here you can use Raspberry Pi for your IoT projects. So if you are someone who is new to IoT field, in IoT it's basically using some of specialized computers or devices apart from the general purpose things. So using this kind of Raspberry Pi board, you can create those kind of specialized computers or specialized hardware to perform some kind of specialized things. In here, in this IoT, you have to connect those hardwares into network. So in this path, a protocol you can use to connect your hardwares into network is MQTT. So if we talk about MQTT works as mentioned here. So in there, your devices can send topics to another devices. So in here, the device could be a computer. In here, the device could be a IoT device. So from your IoT device, you can send data to your computer or any other devices as well. So there is something called broker. Through that broker, you can send those messages, and also by subscribing this broker, you can take the messages sent to this broker. So here it's mentioned what is broker broadly. So here, this is the Mosquito is a open source broker that you can use. So here it's mentioned how to set up this Mosquito breaker on Raspberry Pi and how to get your IoT projects using that. So here it's mentioned how to install Mosquito broker. So if you are running Raspberry Pi headless, which means without a GUI, here with this command, you can install this Mosquito clients and also the Mosquito services. And with this command, you can see if those are installed correctly. Yeah, so with that, you can use your Raspberry Pi for your IoT projects. Yeah, so I'm not going to explain that much. So moving on to our presentation again. This is one of another coolest things that you can do using a Raspberry Pi. It is nothing but robotics. So if you talk what kind of things you can do with your Raspberry Pi in related to robotics, as it works as a tiny computer and also it supports cameras and also the other sensors like lidars and all. You can use those to do slam algorithms and also any other kind of autonomous navigations, those kind of cool stuff that the microcontrollers do not allow you to. So this is in here there is mentioned about the Turtlebot project, which is a standard project that was done using Raspberry Pi and also using ROS2 as well. So as mentioned in here, to build a Turtlebot, you can use a Raspberry Pi and or a Jetson Nano or any other Jetson board as well. So here it's mentioned how to build a robot and what are the components, and in here it's mentioned the components that these boards can help. In there it's mentioned IMU and also the LiDAR. So if you are using a conventional microcontroller, you will never have the privilege of using a LiDAR. So if you are hoping to move on to the robotics world, I think this will be a golden opportunity to you to start. So in this article, it's mentioned how to use Raspberry Pi and the other components and how to build the robot and how to get the things worked and how to do the navigations and all those things. So in here, it's mentioned how to configure Turtlebot with ROS, which can be run in your Raspberry Pi as well. So yeah, and also if you are hoping to run ROS on your robotics project, you will definitely have to install the Linux-based environment like Ubuntu or any other Linux-based environment. So yeah, so apart from that, another cool application that you can do using Raspberry Pi is vision-based projects. So if you are hoping to move your career with computer vision, this is a golden opportunity to you guys as well. So with a Raspberry Pi, you can connect a Raspberry Pi standard camera or any other supported camera to your Raspberry Pi, and using that you can do various computer vision based tasks. So here they are mentioned some details on using webcams and yeah, they mention how to use the webcam using Python and those things. So yeah, if you are hoping to do some kind of projects using projects aligned with computer vision, this is also a good opportunity to you guys as well. So these are the basic things I wanted to explain you guys on Raspberry Pi and its capabilities. So before moving into the pros to the robot operating system, I would like to know if you guys have any other any kind of questions or anything to clarify on the Raspberry Pi platform or any kind of things that you guys like to ask on these things that I have explained. Yeah, so as it seems no one have any questions, so I think we can move in with the next part of the presentation. So I would like to talk a little about ROS2, which is robot operating system that you can run on the Raspberry Pi. So what is ROS2? ROS2 is a open source OS, not basically OS, but we can say it as a service kind of thing that is community driven and that can be very useful if you are doing a robotics project. So when talking about the ROS1 has been around since 2008, and when talking about ROS2, it also comes with Ubuntu support, and it is using TCP and IP middleware just like ROS1, and it is built on DDS communications, and it is providing a good middleware for the robotics. So as I have mentioned previously, ROS is a community-driven platform and which is open source. So if you guys like to learn about ROS, it is basically available in open source, and also if you can do things and you can also publish those things. So moving on, if we talk about the big picture of the ROS in robotics, what we basically doing is sensing the environment and do some kind of process and output the thing by moving some actuators or some kind of other outputting method. So as I have mentioned, in robotics, the softwares are connected to sensors. So in ROS, what they are providing is a stack that is reusable to connect with those softwares and and those are like not provided by any kind of uh, com- any kind of company or something. Those are basically community driven. So if you are using ROS, you can break those huge software stacks into smaller pieces, and you can make them reusable as well. So here, this is the big picture of the robotics. Sorry, the big picture of the ROS operating system. So moving on. So if you are talking about ROS, it is basically same as the MQTT protocol that we have talked previously. In MQTT protocol, what we are doing is some kind of sensors are publishing into some kind of a topics, and another sensors or actuators or anything can subscribe into those topics and fetch data. In here also that same kind of mechanism is happening. So in here also the there is thing called topics which can get the which the sensors can publish us data into, or any other things the processors can take data from. So here the thing that I have talked before, there are thing called topics as which as similar to the broker which was talked in MQTT. So in these topics, the sensors can publish their data in those topics, and any kind of processors like your software is you are running softwares can subscribe those topics and fetch data from that. So for example of the things that can send data to those topics, we can see these kind of cameras, whether they are 2D or 3D, and also these kind of scanners, actuators. So with the actuators, with some kind of odometer readings and those kind of things can send data. So GPS joysticks and all those kind of things can publish data into those topics. After those data is getting published into these topics, any kind of software stacks or processors can subscribe into those topics and fetch those data. So these are some kind of projects that you can do using ROS. So here, this is the unitary go-to robot, and also these are some kind of things you can do with ROS. So this is basically the RWIS2 software which comes with ROS, and this is the gazebo simulator. That's also a software comes with ROS2. So in this gazebo simulator, it lets you to simulate any kind of environments, and also update, upload the URL files, which means the uh, robot robots file, like the robot uh, into the simulated environment, and this lets you to do the algorithms and all those kind of things in the simulated environments and verify the things. In this RS2, this lets you to basically to do the things like mapping. With this, you can see the maps you create. So give me 1 second, please. So moving on, these are some kind of capabilities that you can do using ROS. So in here, there are the maps created with ROS2 and the SRAM algorithms as well, and the robot arms that you can manipulate using ROS2, and those kind of things you can explore if you like to use ROS2 stacks in your Raspberry Pi. So if you like to have a little more understanding on ROS2, there is another thing called nodes. So in ROS2, a node is a standalone piece of functionality, which can be mentioned as a running process or a code piece that is providing functionality. So after running the code, you can create a node, and those nodes are communicating with each other. So in this communication, you can use topics. So basically, these nodes are creating the topics and they are publishing the information into those topics. So here the thing called packages. So the packages are created using several nodes. So nodes, they are providing several packages to yourselves. Like basically the open source community has developed packages and they are providing those so that anyone who likes in robotics can go and use them. So if you are like to do robotics with your Raspberry Pi, this is a good starting point, as you can find a lot of resources from internet and put to your robot which you create and try those things. So as I have mentioned before, here it's mentioned what is a topic. So topic is something that a node can publish data, and another node, which can be a running process, can fetch the data another process is publishing. So a topic can be published by several. So a topic can be published by one publisher normally, and it can be subscribed with several nodes. If one topic is published with several nodes, there can be conflict as well. So those are the basic things that I would like to give you about ROS2 as well. So yeah, so those are the things I wanted to share with you today. So if you guys want to ask me any questions, it's time for you.
So it seems So it seems there is no questions from your side. So let's wrap up that session. So thank you very much for the conducting today's sessions on introduction to Raspberry Pi. Our third year undergraduate from ENTC Sahas. So I think the session provided great value to everyone who attended today. So yeah, let's let's meet on another session of PiMora. So it will be held on near future on this February. So thank you everyone, and good night all.